Hello, I am Mike, K6EEP. First, some background information. Let me explain what I mean by RFI. I'm referring to radio frequency interference that is caused by strong RF fields. Specifically, I'm referring to those fields which are detrimental to the operation of radio equipment. All HF transceivers must be able to operate in diverse environments without internal component failures. While operating at home, you may have an optimal environment with a minimum of RFI present, but when you take the radio into the field, you may not enjoy such pristine conditions. Other radios operating nearby may cause high levels of RFI around your radio, causing interference. Now let me describe the problem. It has been my personal experience that RFI introduced through the radio's external cabling is getting inside some very expensive modern HF transceivers with disastrous results. Blown semiconductors and even discrete components like capacitors are failing. This has caused severe degradation of receiver performance. But why is it happening? These are well-designed radios that perform exceptionally well. They're just put together wrong. It has become a common practice to mount connectors directly on the main circuit boards to keep costs down. I don't like that, but if done properly, I can live with it. However, manufacturers then cut big holes in the radio's case and poke the connectors out without grounding the connector to the case where it exits. They rely on the DC ground on the circuit board to stop any RFI. This is like putting screen doors on a submarine. You cannot let RFI into the case at all. It will choose a path to ground that is not the one you think it will take. Some people argue that RFI should be prevented in the area around the transceiver. This is like saying you should not get your submarine wet. That's what it's supposed to do. A radio should be able to operate within RFI fields without catastrophic failure. As you can see in this set of pictures of a Yaesu FT101E, they used to do it correctly. All RCA connectors were grounded together where they entered the case. Then a jumper was soldered to the chassis. This prevented RFI from flowing down the shielding and getting into places it did not belong. I owned a Yaesu FT2000. I repeatedly had problems blowing out the preamp stages due to the design problem I just described. I replaced the preamp transistors at least 10 times myself. I finally sent the radio back to Yaesu for repair. They replaced an additional 14 components. When I finally got a working radio back, I was determined to try and stop the RFI from getting inside. I found some copper foil at a local electronics store. It is used to repair circuit boards. It has a sticky side so it can be applied like tape. It came in a sheet about 2 inches by 8 inches in size. I cut pieces and stuck them on the back panel of the radio over the connectors. I rubbed on the copper with a wood popsicle stick to make it stick well to the case. Then with an X-Acto knife, I carefully cut openings so that I can just slide in the 1/4 inch and 1/8 inch plugs. When a connector is inserted, it will bottom out against the copper, making a ground connection. One more important construction detail. The sticky side of the copper tape is an insulator. So I drilled through the copper and into the case. Then I tapped the hole to accept a small 256 screw. That way the copper gets grounded to the case. Make sure you do that on all your separate pieces of copper. These photos are not great, but I hope it gives you an idea. On the RCA connectors, I cut an X and slid it over each connector. I soldered the copper to the RCA connector. Be very careful, they don't like heat. Keep the solder close to the case so it will not interfere with the connection. I did test this fix on my FT2000 and it seemed to work, but my ultimate solution was to sell the radio. I hope this works for you. I spent a lot of man hours figuring this all out.